Objective of this experiment is to study the modulation and demodulation scheme of single sideband SSB amplitude modulation system and obtain their waveforms. So as we have already performed double sideband modulation, in which both sidebands we have seen, as well as we used audio oscillator. Today we are going to use the same kit as we have used in DSB, because this kit is for both DSB, SSB modulation, as well as we have a receiver kit. We are going to transmit the signal through both the modes, the wired mode as well as using the antenna, and we are going to see how after demodulation we are going to retrieve the audio signal or not. So today we are going to illustrate this SSB modulation scheme and SSB demodulation scheme. The kit that we are going to use are these two kits, the transmitter kit as well as the receiver kit. In order to display the waveforms, we are using this DSO. We are using both the channels. So as far as SSB is concerned, as you have all learnt in your theory class, that only one band is also capable of sending the whole information from transmitter to the receiver. So using SSB scheme, we can transmit the information using one of the sideband, and the whole information can be communicated. So when we are using SSB, we are making bandwidth half of the as compared to the case of DSB. So in DSB we need to use 2B of bandwidth or 2 FM. Here only FM or only B bandwidth is capable of sending the information, and we are saving the bandwidth at transmitter part, as well as the advantage of SSB is this at receiver part or at demodulation part, we don't need to use a special receiver, but the receiver that we have used in DSB is capable of demodulating the signal, and we are going to get the signal, because we need to multiply the same. If we are using coherent detection, then we are going to multiply the same carrier at the receiver, and after filtering it, we are going to get it back the demodulated signal. So we are not going to invest any extra cost for the receiver, but the same receiver as we have used in DSB can be used to demodulate the signal. So this is the kit we have. Now I am going to power up the kit. This transmitter part, I have powered it up. So we have two schemes, so I need to switch all the knobs to SSB mode. This is audio oscillator that can generate a frequency from 300 Hz to 3.4 kilohertz, as well as amplitude. So we have two knobs, one for frequency and another for amplitude. Today we are going to keep it at 2 kilohertz, some sort of 2 kilohertz of audio frequency. So our message signal is of audio signal nature, and we are going to take 2 kilohertz as a frequency of the audio signal. So our message signal is a sinusoidal nature signal with 2 kilohertz of frequency. This is our message signal. So we are taking this as an input. So this knob is at input select, because we are generating this message signal inbuilt to this kit. If we have any external audio using a mic or any other medium, so we can give that also audio and transmit that using any of the modes, SSB or DSB, and receive it using. So today we are going to transmit this using a wired mode. I'll use the socket mode also, illustrate the socket mode also, and as well as the antenna mode. So we can transmit using socket mode as well as the antenna mode. We will receive it and demodulate it. So we need to receive, or we have to receive or retrieve the message signal back as a sinusoidal, this message signal, sinusoidal nature of this audio signal. So I am going to change this from DSB to SSB. I am just pushing this knob so that we can get the SSB, as well as this one from DSB to SSB. First we are going to transmit through socket, then through antenna. So I am going to use this socket mode. Okay. So as far as SSB generation is concerned, single sideband generation is concerned, we have two standard methods. One can use Hilbert transform or phase method, where you create a phase difference of pi by 2 and then add both of them and then we are going to get the only one sideband. Here what we are using in this particular kit is our filtering method. So we are going to use a filter that can filter one of the sideband. So we are here filtering the lower sideband and we are getting the higher sideband. As you can see, we are taking this balance modulator. This balance modulator has DSB SC output. So we are getting here double sideband suppressed carrier output. So here is carrier is already balanced or suppressed here. So we have balanced the carrier. So here we have both the sidebands, the lower sideband as well as the upper sideband of the DSB SC signal. So if we use a filter here, we are using a filter, and as well as we are using here band pass filter. Using a band pass filter, we are going to separate only the upper sideband. So this output will be our SSB output. So we are going to see how this DSB SC output looks like, and after filtering, how this SSB output look like, and after that this transmission part will be done. Then we will go for reception part. So I have used this probe, this probe. I have used this probe, channel 1 and channel 2. I have connected this to DSB SC output. This output, I have connected this to this output. So I have balanced this. You can balance using this knob so that the carrier gets suppressed. So you can see here in yellow one. In yellow one, you can see we can balance the carrier. When carrier is getting balanced, we are going to get the ideal modulation scheme, where if I'll stop it, then you can see it clearly. This one is our DSB SC output. So here we are getting DSB SC output. So this is our double sideband suppressed carrier output, because we have used this knob. We have used this knob to balance the carrier, and we are getting here DSB SC output. So we just saw on yellow channel that how our DSB SC signal look like. Now after filtration, we are going to see our SSB output. I am going to connect it here to our SSB output so that we can see our SSB output. I will run it so that you can see our SSB output. On the green channel, we have taken our SSB output. This is our single sideband modulated signal. This is our single sideband modulated signal. This is our SSB signal. So this particular signal we are going to transmit, as well as we are going to receive, because this SSB modulated signal must contain the information of our audio signal that we have given as an input. So after demodulation, we need to retrieve this audio signal back. So this is our modulation part, where we have seen the DSB SC modulated signal as well as the SSB modulated signal. This is our modulated signal. If you want to see our the message signal, so I can let you see that also. I have connected that signal at our yellow. So this is our message signal, sinusoidal nature of message signal. You can see this. This is our message signal. So this message signal, this audio signal, we are going to transmit. So at the after receiving, we need to retrieve it back, so that the whole information is getting transmitted, communicated, as well as received at the receiver. So now we are going to use two of the modes here. First of all, I am going to use the socket mode. So we have pushed this knob so that we can use the socket mode. After that, we will see the antenna mode also. I am just transmitting this signal using a socket mode. This is our receiver, so I am switching it on so that we can have this thing. So this is our receiver. I am giving this, since both kits are available at the same place and are close, so we can use wire mode also. So I am just giving it using a wire mode. So whatever we are transmitting from the transmitter, we are going to receive at the receiver. So this is our wired mode. In order to see, in order to detect, we have a tuner, so that we can tune and the particular frequency gets generated, and as we have seen in our DSB AM modulation or demodulation. So we have this thing. So I am going to tune it so that I am going to switch it to the audio so that you can listen to the tone. Now I hope you are able to listen to the tone. Single tone we are going to receive, and that will be our signal. This is our speaker where we can detect the single tone, so that we are assured of that we have received our signal. We need to tune it finally so that we can get exact intensity of the signal. This is our first tone. This clearly verifies that we are receiving the signal using this wired mode. You will see the same thing using an antenna also. So if we want to see the demodulated output, then we need to see it. I am using this knob to show. You can easily see we are receiving the signal. I am just tuning it so that we can receive it completely. So if I will stop it, then you can clearly see that we are receiving the sinusoidal signal with a little bit of distortion, because we have the same frequency as we were transmitting from the transmitter, but there is little distortion because we can't tune it so finely. We can't tune it so fine, so that's why we are getting this little bit distortion. You can see. You can see clearly we are receiving the sinusoidal signal. It's dynamic because it's flowing continuously, receiving the signal and continuously transmitting. So we are going to illustrate the other mode, the antenna mode. So I am going to change the modes. This one. So you can see we are still transmitting using the wired mode, and we have taken this particular input at receiver input. So we are going to receive the signal back. You can listen to the sound also. This is the single tone sound we are receiving using this wired mode, and we are receiving the signal at the receiver part. You can see here clearly that distortion has got removed, and we are getting the exactly sinusoidal signal. So we were getting the distortion because we were not able to finally tune it, but finally we got the tuning back. So we are getting this message signal, the message signal, demodulated wave. This is our SSB demodulated wave. So this is our message signal. So we are going to illustrate here the antenna part. So we have both transmitting antenna and receiving antenna. So here I am removing this wired mode, as well as I am switching these knobs to antenna. I am switching this knob to antenna. So here we are able to transmit using this antenna mode. I am just opening this antenna to the equal height, as well as they need to be close. So yes, so here we are using antenna. So we are transmitting our SSB modulated signal using this antenna, transmitting antenna, and here we are receiving this using our receiving antenna. So we are using here antenna mode. So in order to tune it or demodulate it, I need to see if we are able to receive it. You need to hear the single tone first frequency. I am tuning it. Once we are receiving the signal using this antenna, we are going to get the single tone frequency. As I hope you are able to listen to this. This speaker is making deep sound. This shows that reception is being done, or we are receiving the signal of single tone frequency, because we have sent the single tone frequency from the transmitter part, or a single frequency signal 2 kHz. So we are receiving the single tone frequency here. So in order to see this wave, I need to switch it to the electrical mode, and we will be able to receive the signal back. We will be able to receive the signal accordingly. This is the sinusoidal signal we are receiving, but when we are using antenna mode, then we can expect little bit of distortion, amplitude distortion, but the nature and as well as the frequency of the signal will be same. Nature and frequency of the signal will be same as we were transmitting. So we are getting the sinusoidal nature of signal with the same frequency of 2 kHz, but little bit distortion is there because we are using antenna, as well as we are this particular thing takes time, 5 to 6 minutes to tune it to a particular frequency, so that we can receive the signal. So as we are getting the tone frequency, I need to switch it so that you can. So we have illustrated both the wired mode of transmission as well as the antenna mode of transmission. So here what we have seen up till now, we have the message signal of audio nature of 2 kHz. We have set the 2 kHz of frequency here as our message signal, as the modulating signal, and we have used SSB mode. So we have used filtering method to generate SSB signal. So we have generated using balance modulator DSB-SC output, and after filtration we have filtered out the lower sideband and we have kept the upper sideband. The upper sideband also, and as well as the lower sideband, any of the sideband contains the whole information of the message signal. So SSB modulation saves the bandwidth, as well as without changing the receiver, any modification in the receiver used for DSB demodulation can be used for SSB demodulation. So we are saving the bandwidth and we are sending the whole information to the receiver. And we just illustrated both the mode. We have used the socket mode or the wired transmission, because these both kits are available at the same place, and these are a prototype as well as they are available at the same place. So we have a facility to connect both of them using a wired mode. So we have illustrated the wired mode as well as using the antenna mode. The transmitting antenna transmits the SSB signal, and receiving antenna receives the SSB signal using the receiving antenna, as well as we have demodulated the SSB signal, and we have illustrated both the both mode output. We have received the audio signal of 2 kHz, the same message signal that we have transmitted from transmitter, and this is our SSB modulation as well as demodulation experiment. Thank you.